Hello, welcome back. In this video, we will understand how random numbers can be generated with NumPy. It's exciting, right? So let's get started. So we have worked on arithmetic operations. We have seen how broadcasting plays a vital role in when we work with broadcasting. It's how NumPy array treats arrays with different shapes when we are performing arithmetic operations, right? Now let's work on some other types where we can see how does we can create NumPy arrays in other different ways, right? We have seen with a range function, linspace. We have seen I array, identity array, ones, zeros. We can also use random module with available, which we have seen in Python. We can also use that specific random keyword because all the random functions are part of random module, and we can use them in our NumPy array also, right? So now we'll try to see how we can discover some random functions. So we can also make sure NumPy arrays are filled with or can be filled with random values. They can be filled with random values, and that can be integers or random numbers, whether it can be a mix of positive or negative numbers, because this play a very vital role when we are making sure, when we use this concept, when we try to make our machine learning model trained for particular iterations. That's where random.seed will be using. That means I'll keep up a particular preset value. I'll keep up a value, and I want to make sure for that training it will just reload the same set of values. That's where random is very widely used. So we can fill with random values, and that can be integers or it can have only positive values or negative values depending on it. So first, what we'll try to do is we'll just try to make sure we'll set up a seed value. So where I'll do is I just make sure I give np dot random dot, I'll start with seed. So when I go for np dot random dot seed, so whenever you go for seed, see, this is a convenience legacy function, reseed a legacy. It depends on what we are trying to throw. Suppose if you try to give any seed value, np dot random dot seed, and you don't get any result over here, but let's make sure we try to generate some random value. So I give np dot random dot, first let's try to take rand. So when you take rand value, I mean it's a random value, so creates an array of given shape. Or if you give any value, suppose if you give anything like this, any like 4, so np dot random dot rand of 4, you get 4 random value. It's a one dimensional array, and you run the same cell again, 0.54818888135. You remember this number, just 5488, and observe the change. When you run the cell again, do you see the value changing? No. That's where random will make sure that with the seed reset for 0, for that the same value will appear every time, because we have just make sure with the seed reset every time it will throw the same set of numbers, whether we print randint or randn or whatever it is. So rand will give you, it will throw you the defined numbers, whether it is one dimension or n dimension. So it will, whenever we set the seed, it will make sure that the same set is appearing every time. The same set of numbers will appear every time. This is very, very key point where most of the people will never ever forget. Remember this. So let me make it very simple. If you remove this seed, right? If you remove this seed, just observe it. When you just give rand 4, you see the value change, 4236, the first value. Run once more, it's 0.6963. See, because you did not set the seed, so automatically random numbers will be generated. So that's where seed will play a very vital role when you want to have same set of numbers repeating every time. That's where this random function plays a very vital role, and that is the reason when you're making a transaction, the OTP will not be same, right? It will be different for every time duration, whether it is 3 minutes or 1 minute, depending upon the service provider, they just make it. That is a very key important thing. Now we can go for some other functions. If you want to generate only integers, suppose you want to generate random integer values, but you just want to throw in array format, random integer values. Yes, you can use randint. So for that, what I'll do is, first I'll just make sure I give a is equal to np dot, you need to call the random keyword over here, np dot random dot, you just need to make sure what are the possible functions in it. So when I go for randint, So when I go for randn, it has some input arguments like low, high is equal to none, size equal to none, d type equal to input. That means whenever you can mention the limits, what is the limit you want. So that means suppose if I don't give any limit, it will automatically make sure whatever the size you give, the size is none. That means you could give the size. Something like if you want to have 2, 5, that means it should be only random integers and the shape is, so when you gave 2, 5, what happened over there? It is not taking that as shape. What it mentioned? It is the low value and high value. 2 is your lowest value, 5 is your highest value. That means it will include something like if the values are conformed between 2 and 4, not 2 and 5, right? Because that's where when you see, suppose if you want to make sure you want to pass the array. So make sure you give like this 2, 5, then automatically it gave you, see, even it did not give you, it gave you only 1, 2 because you are passing in the format of tuple. It doesn't make any sense over here. That's where generally when you try to pass every input, then only it will try to throw you the value. So it is very, very important to just make sure first understand when you give 2, 5, when you give 2, 5, this is the lowest value, low is equal to 2, high is equal to 5, but it will not include 5 because the number should be below it, because the interval is it is exclusive, it is not included. 5 minus 1. Suppose if you give 2, 10, every time you run it, you got 9, you run once more, you run this cell once more, you get a different value, right? So this is the first value when you give 2, 10, that means the output will be just a random number. So output will be a random number. Because I want to make it very simple, output will be a random number. It lies between 2 and 9 because 10 minus 1, it is not 10 included. So that is for the first case. When you give print of a, automatically output changes every time. Now I want to include my low and high values along with the shape. So b is equal to np dot random dot randint, because again if you give like this, even you mentioned the tuple over here, so 2, 10, so you see the result over there, what happens? So when you give print of b, so it clearly mentions 0, 1, it's a one dimension. So when you give 2, 1, you try to just make sure b dot, just try to see the shape of it, b dot ndim, you will clearly see it's a one dimension, it lies between 2 and 10, that doesn't make sense, right? So just try to make sure, pass some input here. So you need to mention your starting value, my starting value is 10 and my ending value should lie between, not 90, let me make it as 50, and not 2 by 10, the shape is 2, 5. So you could see the random numbers generated which are integers lying between, int object is not callable because I did not mention comma over here, that is the issue. Just mention your low value, high value, it lies between, see, 2 rows, 5 columns, it is not including 50. Anytime you run, it starts after 10 and ends below 50. That's where you see 49 is the last value, and you run again, the number of elements changes. So this is including your array of shape. So it is including array of shape which is 2, 5. That's how you include. When you go for randint, you generally give low, high and your array of shape. That is with the help of randint. Even you could mention the data type which is integer, whatever it is. So it's up to you. So that's how you could use random integers. Suppose if you want to make sure whether it should lie between, when I want to make sure, if I give randn, that means randn is a specific function, it will always make sure you get some mix of positive and negative values. So the values are always floating point numbers only. So that's where we use randn function, because the values are always floating point numbers only, which includes both positive and negative. It includes, and you may get different results, so don't compare the values. If you are using Colab, I cannot guarantee that you get same values. So always remember, when you're working on random, just make sure if you are setting the seed of 0 or any other value, the values will be same for every iteration. If you don't keep seed, the values will keep on changing. So when you go for randint, low value, high value along with your array shape. So floating point numbers, it includes both positive and negative number. So this is with randn. Let me make it with an example. So I'll give b is equal to np dot random dot. So let's take randn. What are the arguments we have? Say randn 0, d0, d1. It is clearly mentioning that if you don't give anything, suppose if I don't give anything, let's see what would be our result. So when I gave print of np dot random dot randn, you got only one value. It outputs a single floating point number, and you may get it as positive or negative, whatever. See, you got negative. So it gives you a single floating point number because it did not mention any of the shape. Single floating point number. So that's what you could see. Now, if you want to generally give a shape, so just give np dot. There is nothing like low value, high value. You could automatically see when you give random dot randn. If you want to pass the shape, just directly pass the shape like this, 4, 5. And when you print C, you will be seeing an array of shape 4 rows and 5 columns. There you go. It includes positive and negative, and there is no limit. It obviously, the only difference you could see is the mean will be based on the normal distribution. It will be having mean equal to 0 and variance equal to 1. So always you get the values with positive and negative. That is with randn. So if you want to make sure, that is normal distribution. If you want to make sure the values with of uniform distribution, that means it should have some limit where it will lie between 0 to 1. And it also includes only positive values. It only includes positive values. It only includes positive values. It's nothing but some uniform samples over a uniform distribution or samples from a uniform distribution. So for that, let me try to take C is equal to np dot random dot rand. It's not randn. Now if I give rand, so random values in a given shape, and if I just make sure I will not give any input over here with the shape, so automatically it will give you a floating point number again. And anytime you run, there is no positive negative number, and always the limit lies between 0 to 1. It doesn't cross 1. So you could see here. So that's where output single floating point value. The same here, single floating point number. And I'll copy the same comment here and I'll paste it here so that you could easily see. Now, if I try to give my shape, give the shape of an array, np dot random dot randof, make sure you pass the shape. Whatever shape you throw, suppose if I give 3, 2, so it will give the shape according to the field with the random floating point value, that is 3, 2. So that means you could get only the values between 0 to 1, you see 0.09 and everything. So 3 rows, 2 columns. Every time you run, you don't get anywhere negative values. You always get positive value. This is similar to uniform distribution. So this is how you could see how the random numbers are generated by using random function. This is very, very important. So random, so it is similar to random module where we have taken integers, but here you could have the different thing is you could make sure by using randn you could be giving low value, high value, and when you go for randn it includes both positive and negative, and when you go for rand you could see randn is similar to the normal distribution where you could see the mean and variance values accordingly. That's where we have clearly understood when you go for randn it generates both positive and negative, where the floating point numbers based on normal distribution, right? Always mean equal to 0 and variance equal to 1, or variation is equal to 1. And when you go for rand, it is similar to the uniform distribution and always lies between 0 to 1. That is key point. And even if you want to make sure you throw any value as nan or infinity, because INF is infinity is different and nan is different. Nan is not a number, infinity is greater than any other value. That means you can throw any value as infinity. Suppose if I am trying to give an array, ARR is equal to, I want to create a zeros array, np.zeros of, I want to make it as 3, 4. That means this array is completely, so when I throw ARR, everything is filled with 0. That's good, right? Now, specifically, I want to make first row and first column. That means I should, how do I take it? ARR of, just remember the indexing concept, that is 0, 0 or 0, ARR of 0, so that is sub-indexing. You can make it anything. So this will return you this first value. I mean, how can I say first value? Because everything is 0, you could make it simple. So I want to make it as nan. That means how do I call nan? I should take it from NumPy np.nan. That means now ARR of first value will be nan. See, you could see throw some nan value over there, which is not a number. So now if you could cross check whether your array is completely filled or not, you can use a function within it, something like isNan, where again we'll be working on the same things, whether your table is filled or not, your Excel sheet is filled with values or not. We can use is null, not null. We'll be following the same thing. See, test elements for nan and return result as a Boolean array. So is nan of IRR. That means wherever nan is present, it will return you the value true, and in all places it is false because the values are 0. So 0 is different, nan is different. In the same way, if you want to throw one thing as infinity, because INF is greater than any other value, so I'll copy the same thing. I want to make the next value beside nan to be infinity. How could I throw it? I could just give, in place of np.nan, I could make it as infinity. So when I go for np.inf, so that means I could make the next value as infinity. And even if I check, so again if I check np.isNan of ARR, again you try to see the result, what happens? So true, false. So I'll just make sure I run this and I run this again, because I gave infinity, that is nothing but it can be any value. It's not finite, right? That makes the difference. And even if you could check with this, np dot, in place of isNan, you could just throw one more function, is infinity. See, returns a Boolean array of the same shape, test element for positive or negative infinity. And if I throw ARR, so if I throw ARR now, you could see the difference in the result. So wherever you have infinity, it is for true. Remaining all elements, all positions are false. So this is how you could check. You could clearly understand how do you throw the nan value or infinity to a particular thing. And even if you try to use your logical, I mean, we have already seen this or symbol, right? We use the keyword or, and when we have worked on arrays in the beginning, we cannot use that keywords, but we should use the logical arithmetic logical operators. Something like if you give f is equal to, you want to extract both the values, like np dot isNan of ARR, and you use the keyword or symbol, and you could mention np dot is infinity of ARR. And if it is or in the sense, that means it should throw you wherever it is present, it should give you true. See, this is nan and this is infinity. That means you can extract both of them, right? How do you extract them? Just make sure pass ARR of f. Wherever the values are present, it throws you nan and infinity. That's make when you are using or, it is different, right? Or is a logical keyword operator or operator, because I cannot use the keyword. Suppose if I use or like this, you see what is the difference? You see, the truth value of an array with more of an element is ambiguous. Use a dot any or all, because any is any and all are built-in functions in Python. That makes you cannot use the keyword. That is the reason we have used the logical operator. That is a logical arithmetic operator, which is or symbol. That is bar symbol is the keyword. Instead of keyword, we can use the bar. That makes the sense when you're working on logical operators. It's very much important when you work on this. So that is how we have clearly seen what made us to work on these isNan and isinf, because isinfinity is for checking wherever the infinity values are present. IsNan will check wherever we're having not a numbers. The main difference in not a numbers we'll clearly understand when we work on pandas, because wherever the values are filled, it will return true. If it is not filled, it will return false. That's where we see by working on is null, is not null. We have so many things, not null, is null. But make sure we have clearly worked on how do we generate some random values and the difference between rand, randn, randint, and how do we generate random numbers by setting C. This is very, very important. This plays a very vital role when we improve our concepts, because NumPy is the main fundamental package for scientific computing that plays a key role when you're diversifying your career for data science or artificial intelligence or machine learning. Because when you learn such kind of libraries, it's all about how you expand it in your career. So make it very simple, make it very practical, watch out every argument in the function and try to just relate it to the documentation, and this video will be helping for you when you just make sure you are starting step. So just work on the random.ran, random.seed, randint. If you want to have both positive and negative values, you could use randn. If you want only positive values, you could use rand. So in the next video, we will understand about the statistical functions, universal functions, and how we can reshape it. But make sure if you are clear with creating arrays in this way, then those will be very much easier. So in this video, we have understood how to create NumPy arrays filled with random values. As the important point to note is, to access any of the random functions, we need to include keyword random, because all these random functions are part of random module. In the following video, we will work on universal functions on NumPy arrays. Thank you. I hope you have enjoyed watching it. If you have liked our content, please do hit like button and do subscribe to our YouTube channel for more useful content and exciting updates. If you want to learn such practical content at an affordable cost with Microsoft certification and instructor support, please register at academy.codegnan.com. You can also download app from Play Store as Codegnan. Never hesitate to raise queries in the comment section, and please do reply with your suggestions for more practical videos. We'll be happy to come up with it. Thank you.